In section 1.4, we look at writing equations and inequalities. So an equation is simply a mathematical sentence formed by placing an equal sign between two expressions. And then an inequality is very similar to that, except we're going to be using one of these four symbols, which you have likely seen before. One more term here, an open sentence is an equation or inequality that contains an algebraic expression. So we'll see some variables here. And we'll take a look at these symbols. And we have our equal sign, which of course means is equal to. And another way that you could see this worded in a word problem would be the same as. Here we have less than, or this could be worded as fewer than. And to remember less than versus greater than, there are a number of ways to do this. Some people like to, say, draw Pac-Man, something like that, and say the mouth of Pac-Man goes after the greater quantity. Some people maybe draw shark's teeth here. So this is the mouth of a shark opening up to the greater quantity. Whatever it takes for you to remember that this is less than. If we have a bar underneath, then it's less than or equal to. And some common words here would be at most or no more than. So for example, if you had x less than or equal to 5, x could be at most 5 or no more than 5. It can be 5 though. And then likewise we have is greater than, going the other direction, and you could often see this represented with more than, or with the bar underneath greater than or equal to. So if we were to have, say, m greater than or equal to 4, for example, then m would have to be at least 4 or no less than 4, but it could be 4 exactly. Sometimes you could see inequalities combined, and this will be called a compound inequality. And so, for example, sometimes a number can fall between two extremes, a low value and a maximum value. So, for example, if we look at x greater than 5 and x less than 12, we know that x has to fall between 5 and 12. And so the way we're normally going to write this is our minimum value on the left, our variable in the middle, our maximum value on the right. And notice that both of our inequalities are pointed in the less than direction. Sometimes there could be a less than or equal to, but we want them pointed in this direction. And we could read this either x is greater than 5 and less than 12, or a very common way you'll hear this read is 5 is less than x is less than 12. Okay, so we want to look at, in this case, solutions for an equation or an inequality. And a solution is simply a value that when you substitute it for a variable in either an equation or an inequality, it will make that equation or inequality true. So for example, if we're looking at x plus 8 equals 10, if we substitute 2 in place of x here, and we apply our addition, 2 plus 8 would give us 10, so we get this equation, 10 equals 10. That's true, therefore 2 is a solution of that equation. In this case, it's the only solution of that equation. For the inequality x greater than 15, anything that is indeed greater than 15 will work. It'll be a solution for that inequality. So for example, 16 would work, so would 17.5, or 20 and 1/3, etc. Anything that's greater than 15 will be a solution for that inequality. So let's look at some examples here. Write an equation or inequality that corresponds to the verbal sentence. So we want to go from our wording into an actual equation or inequality. So we have the sum of a number. So sum tells us we're going to add. Sum of a number y and 12 is 33. And very often, not in every single case, but very often is shows us where the equal sign goes. So to get the sum of y and 12, we'll take y plus 12, and this is equal to 33. And at this point, that's all we want to do. We don't need to solve the equation, we just want to write it. The difference of the square of a number, m, and 5 is greater than 40. So difference tells us that we're going to subtract. And the and tells us where the subtraction is going to be. So the square of a number m goes first. That will be m squared and 5. So the difference of m squared and 5 is greater than 40. Okay, the product of a number x and 7 is no more than 85. So it could be less than 85. It can be 85 exactly, but no more than 85. So if you want, you could write x times 7. No more than means less than or equal to 85. But of course, the way we're normally going to see this written will be 7x. We normally put the number in front, then the variable, less than or equal to 85. Okay, check if 5 is a solution of the equation or inequality. So we're going to substitute 5 in place of our variable. And then we're going to ask, does 2 times 5 plus 8 equal 18? And we apply our order of operations. We multiply first, and we get 10 plus 8. And we're still asking if that's equal to 18. And then when we add 10 plus 8, we get 18 equals 18, which is a true equation. So this is yes, 5 is a solution because it gives us a true equation. Now if we substitute 5 in place of y, what happens? So we're going to have 5 squared minus 10, and we want to know, is that greater than or equal to 15? This will give us 25. We apply the exponent first. 25 minus 10, is that greater than or equal to 15? 25 minus 10, of course, is 15. And it can be equal, because of the bar being there, it can be equal to 15. So yes, that checks. It is a solution because it gives us a true inequality. So yes. Number 6, here we'll substitute again 5 in place of k. So we have 9 minus 4 times 5. And we want to know, is that less than negative 11? So we have to apply our multiplication first here. 9 minus 20, is that less than negative 11? And 9 minus 20 will give us negative 11. Whoops, there's no equal then. Is negative 11, matter of fact, let me erase that to make it a little more readable. Is negative 11 less than negative 11? No, it is not. This is not a true inequality. So 5 is not a solution of this inequality. It is a solution for this equation and this inequality. Number 7, you and 3 friends went to a movie. So you and 3 friends mean there are 4 people all together. You had a coupon valid for a discount of $5. That's a total discount, not per person, but for the whole group of you, you get $5 off. And together the 4 of you paid $19 for tickets. How much is the normal price per ticket? So you paid $19, but you had a discount of $5. So let's add those together. And that equals $24. That's the normal price for 4 people. So normal for 4 people. So then we'll take that value and divide by the number of people, which was 4. And so the normal price is $6 per person, or per ticket. All right, and finally, number 8. A fitness enthusiast ran 1,000 miles last year. If she runs 20 miles a week this year, will she run more total miles than last year? So we could set this up, and we want to know, we're going to take 20 miles per week, and we're going to have to convert that because we want for 1 year, not just for 1 week. And so I'm going to multiply this times. We have weeks are in the denominator, so we need weeks in the numerator here to cancel out, and we'll have year in the denominator. There are 52 weeks in 1 year, and we want to know, is that more than 1,000? Okay, so when we multiply this out, weeks will cancel weeks. We're going to get miles per year. And when we take 20 times 52, we're going to get 20 times 50 would give us 1,000, and then we're going to have another 2 times 20. So this would give us 1,040 miles per year, which is indeed greater than 1,000. So yes, she is going to run more total miles this year than last year. So there you have it with setting up equations and inequalities. Good luck.